Good morning, student. So this is lecture of analytical chemistry. Now we'll start the chapter number 4, the new separation technique, that is ion exchange chromatography. In this chapter, the syllabus includes introduction about mobile phase, stationary phase, basic requirement of ion exchanger, we called as a stationary phase. Then stationary phase will of the two types, cationic exchange regime and anion exchange regime. Then exchange capacity of resin, cross linkage in resin, then application base, that is effect of pH on separation of amino acid, effect of complexing agent on separation of metal ions, and applications of ion exchange chromatography, and then exercise. So let us see first about the chapter. What is ion exchange chromatography? This chapter discusses about a new separation technique, that is ion exchange chromatography. Ion exchange chromatography is most popular technique for the analysis of amino acids, as ion exchange chromatography we shortly called as IEC, that is ion exchange chromatography, is rapid, sensitive technique than the other available chromatographic techniques. Along with this improvement in ion exchange chromatography or instrumentation part, that is detection, has contributed to make ion exchange chromatography is a popular technique for the analysis of amino acids. Ion exchange chromatography promises to continue as an exciting analytical tool not only for the amino acids but for wide range of other ionic compounds. That means this chromatography is generally used for most of biological molecules or ionic compound for their separation. So here I would like to try to represent a schematic representation of ion exchange chromatography. So this is a column in which the stationary phase is filled. The stationary phase may be cation exchange resin or anion exchange resin. Here is mobile phase, flow from the top of the column and flow through the column. So this is about mobile phase. So mobile phase have plays very important role. That means some molecule have changes their valency with respect to their cations or anions, or with acid or alkaline medium. So in that case the mobile phase should be in a such way that to maintain the same environment or pH of the solution. So this is about the analyte. Separation of ion is taking place on the basis of their exchange capacity with the exchangeable ions with the ionic resins. So this is simple technique. Now we will move to the introductory part, that is introduction of the ion exchange chromatography. Chromatography in its modern forms include a variety of separation methods like ion exchange, ion exclusion, ion pair chromatography. These are the modern techniques in the chromatography. Among these techniques, ion exchange chromatography is an important technique and widely used in order to separate ionic compound by ion partition and ion exclusion phenomenon. Ion exchange chromatography is ideally suited for the separation of those highly polar substances which without recourse to derivative formation and cannot be handled by the gas chromatography. Ion exchange chromatography, the stationary phase has displaceable oppositely charged ion on stationary phase and mobile phase are generally buffer solution that I already mentioned. That means some ions have pH sensitive in order to maintain the pH. So we generally use a buffer system in the mobile phase. Cation and anion exchange process involved in the ion exchange chromatography. Cation and anion exchanger are packed in a glass column and the separation depends on the binding of analyte ions with the positively or negatively charged groups present in a stationary phase resin. So this is about introductory part. Now next point is in introduction the displacement of analyte ion by its coion that is present on the stationary phase during the separation process is the distinctive features of ion exchange chromatography. At the top of the column, the sample mixture is applied or poured and then allowed to pass through the ion exchange material along with the mobile phase. Eluent flow is then resumed and eluent fraction from the column are then collected at regular time interval. Ion exchange chromatography has been used for the analysis of anions as well as cation, include mono and oligosaccharides, metal ions, polyhydroxyl compounds, phenols, antibiotics, organic acids, thiol, peptides, amino acid, amines, alcohols, nucleotides, nucleosides, and other polar molecule. Most of in biological applications are the most influenced by the ion exchange chromatography. Similar to a basic chromatographic technique, ion exchange chromatography consists of mobile phase and stationary phase. So let us see the mobile phase and stationary phase in ion exchange chromatography. First, mobile phase. Mobile phase consists of an aqueous solution of a suitable salt, mixture of salts with a small percentage of an organic solvent, buffer substances which are maintain and control the suitable condition in order to get a proper separation without damaging the analyte with the help of ionic stationary phase. So that I already mentioned. Mobile phase having a combination of substances, that means buffer substances or salt, that they control the pH of the mobile phase and the pH are very sensitive to this system because some molecules showing positively charged ions ionic form in the acidic medium or some shows negatively charged in basic medium. If a pH changes, then the charge on the molecule will ultimately change and that will affect the separation or exchange efficiency of the column. So that's why we should maintain the pH of the solution that will control by using a buffer substances. Next is stationary phase. The stationary phase usually made up from inert organic matrix that is polystyrene divinyl benzene cross polymers, and these cross polymers we called as resins, chemically derivatives with the ionizable functional groups or fixed ion which carry a displaceable oppositely charged ions we called as commonly counter ions, which are easily displaceable. A schematic representation of the stationary phase is as shown in the figure. On the basis of their exchangeable ions and stationary phase are classified as anion exchange region and cation exchange regions. So it is in the form of small beads. So there are two types of stationary phase, ion exchange, that is anion exchange, and cation exchanger. So here we try to represent a schematic representation of a stationary phase. It is in the form of beads. So it is simple cross polymer, polystyrene divinyl benzene cross polymer. Here we showing this is the polymeric chain, this dark black color, and this paint gray color is cross link, that is it is cross linked by divinyl benzene. I already mentioned that is divinyl benzene cross link polymer. So this polystyrene, this is polystyrene polymer chain length, and this will be cross linked with the divinyl benzene. So this is cross linking, here would like to show. And this spherical part, that is gray part, is negatively charged fixed groups, that is fixed functional group present in the resin or on polymer chain, that is this negatively charged. This is a anion cation exchange resin. So ultimately anionic group is fixed into the polymer chain, and this is exchangeable ion, that means positively charged or exchangeable ion or easily displaceable, or we call as counter ion. So this will change with the other positively charged ion. So this is exchangeable ion, all positive charge are exchangeable, that means this is a resin for cation exchange region. So here we would like to try in a single schematic representation. So this is about the stationary phase. So basic requirement for the ion exchange region. So there will be some basic requirements or minimum characteristic that should be there in the stationary phase. So then it will be useful for the use as a stationary phase. So there are several basic requirements. So let us see one by one. First, it must be sufficiently hydrophilic to permit the diffusion of ions through the structure at a finite and usable rate, right? So it is sufficiently hydrophilic, so then it will be permit or diffuse the ions through the structure. Second requirement is it must be sufficiently cross-linked, that I already mentioned that divinyl benzene is cross-linked by polystyrene. So sufficiently cross-linked to have only a negligible solubility. So solubility is negligible. Third basic requirement, it must be chemically stable and must contain a sufficient number of accessible ion exchange groups. So that I already mentioned, it is chemically stable, and this accessible functional group is there sufficient, that means here negative, 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 negative. So that must be sufficiently in this region. Cross linkage also sufficiently, uh, so we can get the accessible ion exchange capacity. So fourth is reversibility and no permanent change in the structure. So these exchangeable ions are again replaced with the other counter ions. So this process is reversible, so it is not permanent exchange, so that should be there. Fifth requirement, after swelling it must be denser than mobile phase. If you soak into the solution, so it will be a swell like a polymeric bead. So this swelling, after swelling, what happened, the polymer beads or resin should be denser than the mobile phase, otherwise what happen, the bits will be on floating on the mobile phase when you add the mobile phase. So density should be greater than the mobile phase after swelling. Last requirement, ion exchange separations are usually carried out in a column consist of ion exchange regions. There are two types of ion exchange regions, that is cation ion exchange region or anion ion exchange regions, or we call as cation exchanger or anion exchanger. So that we will see in the next lecture. Now we'll stop the lecture.